Hey everyone, it's Mr. Canfield. Today we're going to be doing the Chapter 1.1 and 1.2 quiz review for geometry. So I'm just going to do my best to explain everything here, just in case you weren't in class or you missed something as we were doing it. So in the figure above it says DC is 14. So from D to C, that's 14. So one thing you can do, you can mark it. It says AE is 10. So AE, that's 10. Okay. So now I got the information from the text. Let's see what we can do. It wants to know what BC is. Let's see. BC is from here to here. I just got that double mark on it. Well, let's see. Oh, here's double mark 7. So double mark means 7. That means that this has 7 as well. Okay, that's BC. EB. Let's see. That's from E to B. It's got the single mark. Well, here's another single mark, and that says it's 5, so that means this is 5. And then BEC, remember you do it in that order, B, then E, then C. BEC. So that little guy there, it's a single mark, angle, and oh, here's an angle with a single mark, so 35 degrees. Okay. The easy stuff is out of the way. It's just recognizing that those marks mean they're congruent, or the same thing. Is AE equal to CE? Back it up with evidence. Well, let's see. AE is from here to here. That's, oh, we know AE is 10 already. So really the question is like, is CE 10? Well, I know CE is right here. I also know the whole thing here, right? I know this is 5, and I know the whole thing is 14. So couldn't I say 5 and then whatever CE is, together that's 14? So why don't I just do 14 minus 5, and that'll find out this piece that I'm missing. So 14 minus 5, you can use your calculator if you need it, it's 9. So, is 10 equal to 9? No. One's 10, one's 9. So we could say AE equals 10, CE equals 9. That's not equal to each other. All right. Next, we come to a number line. All right, on this number line, we see this is 3x minus 5. We see this is 4x minus 6. That's like from here to here, that's how far it is. From here to here, that's how far it is. And from here to here, that's how far it is. If we knew what x was, we could actually plug it in and find these different things. So it says, given that AD is 22, find x. Oh, okay. So let's see, AD, that's from A all the way to D. Oh, that's the whole thing. Okay, if it had been like BD, we would just use these two parts, but since it's AD, it's the whole thing, we'll use the whole thing. So I can say 3x minus 5 plus 4x minus 6 plus, oh, it's a negative 3x, plus negative 3x plus 17 is equal to 22. Cool. So that's a big mess, but it's really just saying, take all the x's and add them up. So 3 plus 4 plus negative 3. So 3 plus 4 is 7, plus negative 3 is back down to 4. So we have 4 x's, and then minus 5 minus 6 plus 17, that's negative 11 plus 17, so that's plus 6. So 4x plus 6 is equal to, oh, and then 22 is still there. So now we have this nice little equation, 4x plus 2 is equal to, 4x plus 6 is equal to 22. So I'll subtract the 6 from both sides, get 4x is equal to 16. And then divide both sides by 4 and get x is equal to 4. Okay. Let's see, AB. Oh, it just wants to know what AB is. Well, AB is 3x minus 5, right? So I know x is 4, so we do 3 times 4 minus 5, which is 12 minus 5, which is 7. Okay, 7. And then it wants to know BD. So I could plug 4 into both of these, which is totally fine. I'm gonna show you a little trick on, let's see, so it's 16 minus 6. I got 10 for this piece, and then negative 3 times 4 plus 17, so it's negative 12 plus 17, and so 5. I'm a little pressed for time, so I'm not really giving you a chance to think. I hope you are able to use the pause feature of YouTube to make this a useful video. Pause and rewind are really helpful. Okay, so I want to know what B to D is. Well, I got 10, I got 5, so together that's 15. That's not how I did this the first time I did this problem, though. I knew that AB was 7, right? And we knew that AD, the whole thing, is 22. Well, if this is 7 and the whole thing is 22, I just did 22 minus 7 to get what was left over. So, doesn't always work, but in this problem, that was a little bit of a simple way to do it. Okay. Then we get over to this one. It says in the figure to the right, the angle AB is equal to 90, so that's ABE, right? That's this whole angle here is 90. So I'm not even going to pay attention to this yet. That's like saying it's this angle here and this angle here together is 90. All right, now let me go pay attention. All right, CBE. CBE is, oh, we want to know that one. So we want to know this piece. So we know this piece and the 35 together is 90. So we just need to find the missing piece. So we could do 90 minus 35, and that's going to give us what goes there. Well, 90 minus 35 is not 60 because there's that 5 there, so it's 55. So 55 degrees. So this is a 55-degree angle. So we got a 35, a 55, and then there's a little 30 down here. So ABD is, let's see, AB, oh, it wants to know the whole thing, ABD. So 35, so I just go 35 plus 55 plus 30, which is 120. Cool. Then it says a CBD 90 degrees. Let's see, CBD, let's see, let's look at this. It looks like it is, but we should add the numbers up. So it's these two numbers here. That's what add up to CBD. 55 plus 30 is equal to 85. Nope. Or nopers. All right. And then I can't stress this enough. So this is like bonus level. This is, you need to know how to do this. All right, so I'm gonna find the perpendicular bisector. So remember how this works. We take our compass, we put the rotating point here, and then we pick a spot that is more than halfway. This compass doesn't have a lot of markings left on it, which is unfortunate. So I'm gonna pick this one and just mark it. And if you think about what we're about to draw, where we're going, my goal is to put something through the middle here. So I want to make sure that I make it all the way up to here and here. Oh, good, I found my mark. So I go here and I do this, you know, kind of half moon shape. And then I go over to the other end point of the line segment. I put my compass and I gotta find the exact same spot. And I'm trying to find where does it cross there. So I don't even have to draw the whole half moon here. You definitely can though, but I only really care about where the two half moons cross. So a lot of people, when they do it, they actually will leave out most of it and they'll just have a little cross and a little cross. And then we take our ruler, let me put dots there, it helps me out. Put dots in, line it up, and boom. So this thing I just drew, that's like the answer to the question. The half moons don't count because I want a perpendicular bisector. Look at that 90-degree angle. And then look, see how I can even take a, oh, I don't have, but that's the whole, and like it's the same amount of holes lined up. Okay. So yeah, perpendicular bisector, probably the most important thing we do with these compasses is getting that. All right, so then for this one, remember on the handout, I did not quite make this long enough, so I'm just gonna make this a little bit longer here. Okay, so let me make it No, it should be good over here. So what I'm going to do is pick some random arc. It doesn't matter which one of these I pick. I'll just do I'll do this one, and then I go down somewhere else and I do it again. And I want to make sure this one is at least as big as the one I drew over here. And what I'm going to do is put a dot in my center and just anywhere I want in here, just connect them. So that's the first step. The second step is we take our compass and we find out this opening here. So looks like I got to use that dot to make that open. So I'm going to come over here and put my center on this crossing and see where it crosses the arc I drew over here. When I connect those, that means that and that are the same angle. So, hope this video was helpful. Feel free to email me or talk to me if you have any questions about it. Until next time, bye.